हेलो नमस्ते दिस इज निखिल एंड वेलकम यू टू द पीपीज लर्निंग लैब। गाइस आज आपके लिए मैं एक जबरदस्त और खतरनाक टॉपिक लेके आया फ्रॉम केमिस्ट्री। चलिए, केमिस्ट्री इज ट्राइंग टू बी समथिंग। केमिस्ट्री इज ट्राइंग टू बी समथिंग, समझ में नहीं आया क्या? देखो, केम इज ट्राइंग, केमिस्ट्री इज ट्राइंग टू बी समथिंग and built a kingdom named organic chemistry on the powers of the carbon. So great, right? Chile guys, let's look into the past. In 1780s, the chemists of those days, they decided that all the compounds which are prepared or synthesized from the plants or animals are called as organic compounds, and all the products or compounds which are produced from the minerals are known as the inorganic compound. But as the days passed on, in 1828, a chemist from Sweden proved that organic compounds can also be produced from inorganic compound by synthesizing urea from inorganic compound ammonium cyanide. This is the first milestone which created in the history of organic chemistry. Ammonium cyanide, when it's heated up, slowly heated up, it changes into urea. This is a organic compound and it is also known as the food to the food. See, when we ammonium cyanide is slowly heated up, we get urea. This method is also known as Euler's method. Euler method. And he is the first chemist who synthesized the organic compound from the inorganic material. Coming to the powers of the carbon, which made to build a kingdom named organic chemistry, the first and the foremost power is the tetravalency of the carbon. The carbon whose atomic number is 6, right? The electronic configuration will be 1s2, 2s2, 2p2. This is the electronic configuration in which the outermost orbit may 4 electrons, right? 4 electrons. So to get octet rule, electron need 4 more electrons. Carbon need 4 more electrons, right? So the valency of carbon is 4. So there is the first power, that is tetravalency. Valency is capability of forming bonds. And coming to the power number 2, carbon can form multiple bonds with other carbon atoms and also with atoms like oxygen, nitrogen, sulfur, and so on. See guys, one day what happened is carbon thought that, yeah, I have 4 electrons in my outermost orbital, then why should I need to beg 4 more electrons, or why should I need to donate 4 electrons to get stability? And it's used its brain like our girls use some rarely, and decided that it's ready to share its electron to form the bond, and thus it formed the covalent bond. Covalent bond. So second power is carbon is capability of forming covalent bond, multiple bonds with other atoms, and the bonds are of covalent. And we already know that covalent bonds are the strongest bond among the all chemical bonds like hydrogen bonds or ionic bond, right? So this is the power number 2. And coming to the power number 3, carbon have a unique property known as catenation property, through which it can bond with any number of carbon atoms to form a long chain, a straight chain or branched chain or a ring chain, a ring, and so on. So catenation property is the power number 3. Here the question arises. Let's see the question. We already know that all the elements in a same group are having the similar properties. So carbon, silicon, germanium, tin, lead are a 14th group element, and they are all having the 4 valency electrons, and they are capable of forming the covalent bonds. At certain conditions, some of the elements like germanium, tin can form the ionic bond. It's a different topic, but they are also capable of forming the covalent bond. and they are having the tetravalency, I mean 4 valency electrons in their outermost orbit. And some at up to certain extent, silicon can also shows the catenation property. But why can't all the elements other than carbon are not able to form the long chain compounds like our carbon is forming? The reason is, we already know, yaar, as we go down in the group, the atomic size will be increased. As the atomic size increases, what happens? The nucleus, the attraction power of the nucleus towards the straight pair of electrons will be reduced, so that the bond will be weak. As the atomic size increases, the bonds which formed by the atoms will be weak comparing to our carbon. This is the reason why other elements other than our carbon are not able to form the long chain compounds like carbon forms. Let's do one problem यार, तो समझ में आ जाएगा पूरा. देख लेना, सवाल देख लेना. Silicon is also tetravalent and forms covalent bond with other atoms and also shows catenation property like our carbon shows. But why can't it forms long chain compounds like carbon? This is the question. Coming to the option A, silicon does not form polymers because of its semiconductor nature. Yes, ये तो गलत बात है ना. Silicon is not forming polymers because it's the bonds which are formed in the silicon, I mean when it is bonded with other silicon atom, the bond will be weak because the atomic size is large, right? So the attraction power of the nucleus towards the straight pair of electrons will be less. So it is the reason. The reason is it's not able to hold the electrons, straight pair of electrons, to not to form the polymers. This is the reason. So the first option will be wrong, right? So coming to the option C, silicon compounds are highly reactive. Yes, ये तो सही बात है. As we go down into the groups, the reactivity nature of the elements will be increases. So ठीक है, but it's not related to our question, right? And coming to the D, carbon compounds are moderately reactive. ये भी सही है, but it's not related to our question, right? The correct answer will be carbon is small in size, so holds the straight pair of electrons strongly. ये तो सही है, right? So guys, you can have the screenshot of the explanation.